Hello everyone. In this video, we'll see some sample questions for Google Cloud Professional Data Engineer certifications. Most of the questions are scenario-based questions here. Let's see few of them in this video. The first question is, you're working on a sensitive project involving private user data. You have set up a project on Google Cloud Platform to house your work internally. The external consultant is going to assist with coding a complex transformation in Google Cloud Dataflow pipeline for your project. How should you maintain user privacy? The given options are, the first one is grant consultant the viewer role on the project. Second option is grant consultant the cloud data for developer role on the project. Third option is create a service account and allow the consultant to log on with it. The fourth option is create an anonymized sample of the data for the consultant to work within a different project. The key points to consider in these questions are, the first one is it's a sensitive project which has user information. The second one is giving access to the external consultant to assist with the complex coding in a Google Cloud Dataflow pipeline. So these are the two key points here. Considering these 2 points, let's go into each of the answer here. The first one is grant consultant the viewer role on the project. So if you provide a viewer role, even then the consultant can see all the sensitive information. So this is not the right answer. The next option is grant consultant the cloud data for developer role on the project. So again, if you give a cloud data for developer role, even then the consultant can view all the sensitive information. So again, this is not the right answer. Move on to the third answer, create a service account and allow the consultant to log on with it. So again, if you create a service account and allow consultant to view the data, then even then the consultant can see the sensitive information. So this is also not the right answer. The fourth option is create an anonymous sample of the data for the consultant to work with a different project. So when you have anonymous data, the sensitive informations are removed and the source of the data cannot be identified. So in that case, and also we're going to give that data in a different project. So in that case, the consultant cannot view the actual information of the user. So in that way, we can protect the user information. So option D is the right answer here. Moving on to the next question. The next question is, your company is streaming real-time sensor data from their factory floor into a Bigtable and they have noticed extremely poor performance. How should the row key be redesigned to improve big data performance on the queries that populate real-time dashboards? The given options are, first one is use the row key of the form timestamp. Second option is use the row key of the form sensor ID. Third option is use the row key of the form timestamp sensor ID. And the fourth option is use the row key of the form sensor ID timestamp. Here the question talks about streaming real-time sensor data into a Bigtable and they noticed a very poor performance. They want to redesign the row key to increase the performance. So we need to find the best one from these 4 answers. Before going to these 4 answers, let's quickly see a note on the row key. These screenshots are from the above link, and what does it says is like, what are the things we should avoid when you define a row key? The first one is row keys that start with the timestamp. Other one is sequential numeric IDs. So these things we should avoid when you define a row key. So the row key that starts the timestamp we should avoid, and sequential numeric IDs. For time-based data, we should include the timestamp as part of your row key, and do not use timestamp by itself or at the beginning of a row key. So for time-based data, we need to include timestamp as part of a row key, but don't use timestamp by itself or at the beginning of the row key. So that are things we need to consider before defining a row key. The first one is don't begin the row key with the timestamp, or also don't provide sequential numerical IDs as a row key, and don't use timestamp alone in the row key or at the beginning of the row key. For the time-based data, use timestamp as part of your row key. So these are the points we need to consider before choosing an option. Now let's go into the options. The first one is use the row key of the form timestamp. So this one we should avoid because timestamp cannot be we cannot start with the timestamp, or we cannot have the timestamp alone in the row key. So we can eliminate option A. The second option is using a form use the row key of the form sensor ID. Since it's numeric ID, we should eliminate this also. Third option is use the row key of the form timestamp sensor ID. So we cannot use timestamp at the beginning of the row key, so we can eliminate this. So the option is D, use the row key of the form transfer ID timestamp. So for time-based data, you should include a timestamp at the part of your row key. So for option 4 is the right answer here. The next question is, your startup has never implemented a formal security policy. Currently, everyone in the company has access to the datasets stored in the Google BigQuery. Teams have freedom to use the service as they see fit, and they have not documented their use cases. You have been asked to secure the data warehouse. You need to discover what everyone is doing. What should you do first? The options are: first one is use Google Stack Driver audit logs to review data access. Second option is get the identity and access management policy of each table. Third one is use tracked monitoring to see the usage of BigQuery query slots. Fourth option is use the Google Cloud Billing API to see what account the warehouse is being billed to. The key points in the questions are like, we need to set up a formal security policy. Other one is we need to identify what everyone is doing. So by looking at the answer, we can clearly say that option A is the right answer, because with the help of Google Stack audit logs, we can easily review data access, like what everyone is doing, and also we can implement security policy based on that. Other options does not fit for this question, so the right option is A here. The next question is, your company is migrating their 30-node Apache Hadoop cluster to the cloud. They want to reuse Hadoop jobs they have already created and minimize the management of cluster as much as possible. They also want to be able to process data beyond life of the cluster. What should you do? The options are: the first one is create a Google Cloud Dataflow job to process the data. Second option is create a Google Cloud Dataproc cluster that uses persistent disk for HDFS. Third option is create a Hadoop cluster on Google Cloud Compute Engine that uses persistent disk. The fourth option is create a Cloud Dataproc cluster that uses Google Cloud Storage Connector. And the fifth option is create a Hadoop cluster on Google Compute Engine that uses local SSD disk. The key points in the questions are: the first one is we are migrating 30 node Apache Hadoop cluster to the cloud, and we want to minimize the management of cluster as much as possible. The third one is data has to be persisted beyond the life of the cluster. So these are the key points here. Since we are migrating Apache Hadoop cluster to cloud, then the right service would be Dataproc. So the options either it should be B or D, because these two options are talks about Dataproc. Remaining option does not have Dataproc as an option. So from the B and D, we need to find out the right answer here. And the next point we need to answer here is we want to process the data beyond life of the cluster. So when you use persistent disk for HDFS, once the cluster goes, then data also goes after the life of the cluster. If you want to store the data beyond the life of the cluster, then we need to use Google Cloud Storage Connector to store the data beyond the life of the cluster. So the option right here is the correct option here is D. The next question is, you want to process payment transaction in a point of sale application that will run on Google Cloud Platform. Your user base could grow exponentially, but you don't want to manage infrastructure scaling. Which Google database service should you use? The options are: first one is Cloud SQL, second one is BigQuery, third is Cloud Bigtable, and fourth option is Cloud Data Store. Here the key point of the question is, it's a payment transaction and the user base could grow exponentially, and we don't want to manage the infrastructure scaling. So these are the key points in this question. Let's quickly see the Cloud Data Store documentation page. So this screenshot is from the above link, and what does it say is like, data store is a NoSQL document database built for automatic scaling, high performance, and ease of application development. The features include atomic transactions, high availability of reads and writes, massive scalability with high performance, flexible storage and querying of data, balance of strong and eventual consistency. So these are the key features provided by data store. For our question, we need automatic scaling, so data store provides that automatically. Whereas Cloud SQL, this feature is not available. We need to manually make some adjustment to make it scalable. So from the given option, the correct answer is D, Cloud Data Store. The next question is, your company's on-premises Apache Hadoop servers are approaching end of life and IT has decided to migrate the cluster to Google Cloud Dataproc. A like-for-like migration of the cluster would require 50 TB of Google persistent disk per node. The CIO is concerned about the cost of using that much block storage. You want to minimize the storage cost of the migration. What should you do? The options are, first one is put the data into Google Cloud Storage. Second option is use pre-immutable virtual machines for the Cloud Data Pro cluster. Third option is tune the Cloud Data Pro cluster so that there is just enough disk for all the data. The fourth option is migrate some of the cold data into Google Cloud Storage and keep only the hot data in persistent disk. Here the question talks about migrating the Apache Hadoop servers to Google Cloud Dataproc, and it's a like for like migration. From the given options, what Google recommends is when you migrate data from on-prem to cloud, use Google Cloud Storage. So this is what Google recommends. So the option here is A, put the data into Google Cloud Storage. But let's see other options also. Second option is use pre-immutable virtual machines for the cloud data store cluster. So this option might saves the compute cost but not the storage cost. But here the question talks about minimizing storage cost, but the second option talks about compute cost. So B is not the right answer. The third option is tune the cloud data pro cluster so that there is just enough disk for all data. Again, it's a kind of like to like migration, and also the question doesn't talks about tuning of the cloud data pro. So this is not the right answer. The next option, migrate some of the cold data into Google Cloud Storage and keep only the hot data and persistent disk. Here the question doesn't talk about cold data and hot data, and there is no information about this one. And also again, keeping the hot data and persistent disk gonna cost more compared to Google Cloud Storage. So D is also right, not the right answer. So the right option is A, put the data into Google Cloud Storage. This is what Google recommends. The next question is, you work for a car manufacturer and have set up a data pipeline using Google Cloud PubSub to capture anonymous sensor events. You are using a push subscription into Cloud PubSub that calls the custom HTTPS endpoints that you have created to take actions of these anonymous events as they occur. Your custom HTTPS endpoints keep getting an inordinate amount of duplicate messages. What is the most likely cause of these duplicate messages? The given options are, the first one is the message body of the sensor event is too large. The second option is your custom endpoint has an out of date SSL certificate. Third option is the cloud PubSub topic has too many messages published to it. Fourth option is your custom endpoint is not acknowledged messaging within the acknowledgement deadline. The key point in the question is the custom HTTPS endpoint keeps getting an inordinate amounts of duplicate messages. Since we are getting more and more duplicate messages, the reason could be the fourth option. The custom endpoint is not acknowledging the messages within the acknowledgement deadlines. So when there is no acknowledgement, the PubSub keeps sending the messages. That's the reason we could see more duplicate messages. So right option is here is D. The next question is, your company customer and order database are often under heavy load. This makes performing analytics against them difficult without harming operations. Database are in a MySQL cluster with nightly backups taken using MySQL dump. You want to perform analytics with minimal impact on operations. What should you do? The options are, the first one is add a node to the MySQL cluster and build an overlap cube there. Second option is use an ETL tool to load the data from MySQL into Google BigQuery. Third option is connect an on-premise Apache Hadoop cluster to MySQL and perform ETL. The fourth option is mount the backups to Google Cloud SQL and then process the data using Google Cloud Dataproc. This question talks about performing analytics on the MySQL database with minimal impact. How we can do this? First, let's see about option C and D. Option C talks about connect an on-prem Apache Hadoop cluster to MySQL and perform ETL. Here you want to perform some analytics on the data, so we don't need to connect an on-prem Apache Hadoop cluster to MySQL and then perform ETL. So we don't need to do this to perform analytics. So option C is not right. And also the option D, mount the backups to Google Cloud SQL and then process data using Google Cloud Dataproc. Cloud Dataproc is mainly used for Hadoop kind of data, Hadoop for big data processing. So here, because here we are not migrating any data from Hadoop to GCP, so there is no need for a data cloud data proc. And also question talks about perform analytics. The cloud data proc is mainly for processing data, but here we talks about analytics on the performing analytics on the data. So option C and D are not true. So we are option left with A and B. Now let's look at the option A. Option A is add a node to the MySQL cluster and build an OLAP cube there. So the question is, it's already the database under heavy load. We don't want to impact that database. So adding a node to MySQL cluster and building OLAP cube there, again it's gonna harm the database, harm the operations. So option C is not right, and we are left with option B. Option B is use an ETL tool to load data from MySQL into Google BigQuery. So this is the right answer here. Use the ETL tool to load data from MySQL into BigQuery. This will help you do the analytics. So option B is the right answer here. The next question is, you are designing a basket abandonment system for an e-commerce company. The system will send a message to the user based on these rules. First one is no interaction with the user on the site for 1 hour. Second one is has added more than $30 worth of products to the basket. Third one is has not completed a transaction. You use Google Cloud Dataflow to process the data and decide if a message should be sent. How should you design the pipeline? First one is use a fixed time window with a duration of 60 minutes. Second option is use a sliding time window with a duration of 60 minutes. Third option is use a session window with a gap time duration of 60 minutes. Fourth option is use a global window with a time-based trigger with a delay of 60 minutes. The question here talks about the user interaction on the site. So when there is no interaction with the user on the site for more than 1 hour, then we should send out a message. By looking at the answer, the fixed time window and the sliding time window, those are like fixed time interval, fixed interval. So we cannot use this option here because here we cannot have a fixed interval. So and also the question talks about user interaction on the site. So it is a session window. So the right option here is C, use session window with a gap time duration of 60 minutes. The fourth option here, use global window, the time-based trigger with a delay of 60 minutes. There is no concept of global window as per the documentation available in the link. So the correct option is C here, use the session window with the gap time duration of 60 minutes. If you want to learn about more about this window, just go into this link. You will have to find the documentation of these windows. The next question is, you need to store and analyze social media posting in Google BigQuery at a rate of 10,000 messages per minute in near real time. Initially, they designed the application to use streaming inserts for individual postings. Your application also performs data aggregations right after the streaming inserts. You discovered that the queries after streaming insert do not exhibit strong consistency, and reports from the queries might miss in-flight data. How can you adjust your application design? Options are, the first one is rewrite the application to load accumulated data every 2 minutes. Second option is convert the streaming insert code to batch load for individual messages. Third option is load the original message to Google Cloud SQL and export the table every hour to BigQuery via streaming inserts. The fourth option is estimate the average latency for data availability after streaming inserts and always run queries after waiting twice as long. The key point to consider in the questions are, first one is we need to analyze the social media posting in a near real time, and also we discovered that queries after the streaming insert does not exhibit strong consistency. The report might miss the in-flight data. So we just need to adjust the application design here. Now let's quickly see the options one by one. The first option is rewrite the application to load accumulated data every 2 minutes. So here we are talking about rewriting the application to load the accumulated data every 2 minutes. So here they are talking about 2 minutes, but nowhere in the question saying that it is like because of the time interval there is some issue, because they did not mention about any time interval as 2 minutes anywhere in the questions. But here we are saying that we are going to rewrite the application to load the accumulated data every 2 minutes. So that does not solve the issue here. Still we have the possibility of missing the in-flight data. So rewriting the application will not solve this issue. Next one is convert the streaming insert code to batch load for individual messages. Again, this question here, what they're saying is they convert the streaming insert code to batch load, but we need to analyze this data in a near real time. But here we are talking about the batch mode. So since the batch mode, we cannot expect a real time data. So again, option B is not the right answer here. Let's move on to the third option. Third option is load the original message to Google Cloud SQL and export data every hour to BigQuery via streaming inserts. Since again we are talking about the near real time, so again exporting to table every hour to BigQuery via streaming inserts will not solve this issue here. So we are left with only option D here. Option D is estimate the average latency for data availability after each streaming inserts and always run a query after waiting twice as long. So this looks is the right answer here, because what we are trying to do here is we're gonna find the average latency of the data availability, and then we're gonna wait twice as long of this one. So in that case we'll not miss the in-flight data, so we'll get all the, because we're going to wait twice as long as the average latency of the data availability. So D is right answer here. Option is D. Estimate the average latency for data availability after streaming inserts and always run queries after waiting twice as long. The next question is, you need to copy millions of sensitive patient records from a relation database to a BigQuery. The total size of the database is 10 TB. You need to design a solution that is secure and time efficient. What should you do? And the four options are: export the records from database as an Avro file, upload the files to GCS using GSUtil, and then load the Avro file into BigQuery using a BigQuery web UI in the GCP console. The second option is export the records from the database as an Avro file, copy the file onto a transfer appliance and send it to Google, and then load the Avro file into BigQuery using a BigQuery web UI in the GCP console. The third option is export the records from the database into a CSV file, create a public URL for the CSV file, and then use the storage transfer service to move the files to cloud storage. Load the CSV file into BigQuery using a BigQuery web UI in the GCP console. The fourth option is export the records from database as an Avro file, create a public URL for the Avro file, and then use the storage transfer service to move the files to cloud storage. Load the Avro file into BigQuery using a BigQuery web UI in the GCP consoles. So these are the four options. So uh, this question is they mainly deal with copying millions of sensitive patient records from a relation database to a BigQuery. So here we are talking about sensitive patient records. So since it's a sensitive data, we cannot create a public URL for this one. So because of that reason, option C and D we can eliminate, because creating a public URL is not good to have. I mean, it's not good for a sensitive patient records. So we can eliminate C and D and leave that left with option A and B. So we need to choose our answer from A and B, either A or either B. Before going to option A and B, let's see a concept on data migration from on-prem to cloud. You can find this Tableau column in the above link. So it is mainly on data size and the network bandwidth. The horizontal is the network bandwidth and the vertical is the data size. So in our case, we have 10 TB of data, and we are assuming we have a network bandwidth of 1 Gbps. Then within 30 hours, we can transfer data from on the on-prem to the cloud. Suppose we have 10 Gbps of bandwidth, then within 3 hours we can transfer the file from your on-prem to the cloud. So considering this one Tableau column, we can easily say that we can easily within 30 hours we can do the transfer. Whereas if we use the transfer appliances, we need to send the data to the Google, and then from Google they need to upload the files into the cloud. So it's going to time consuming. But the question is mainly on the time effective option. So in that case we can go with option A here, that is export the record from a database as an Avro file, upload the file to GCS using GSUtil, and then load the Avro file into BigQuery using the BigQuery web UI and GCP consoles. So this is could be the apt answer here, because the second option we need to transfer. You should use the transfer appliances and send it to Google and then load the file. This could be more time consuming compared to the option one here. So with that, we conclude that option A is the right answer for this question. The next question is, you need to create a near real-time inventory dashboard that reads the main inventory tables in your BigQuery data warehouse. Historical inventory data is stored as inventory balances by item and location. You have several thousands of updates to inventory every hour. You want to maximize performance of the dashboard and ensure that data is accurate. What should you do? And the four options are: First one is leverage BigQuery update statement to update the inventory balance as they are changing. Second option is partition the inventory balance table by item to reduce the amount of data scanned with each inventory update. And the third option is use the BigQuery streaming the stream changes into a daily inventory movement table. Calculate the balances in a view that joins into historical inventory balance table. Then update the inventory balance table nightly. The fourth option is use the BigQuery bulk loader to batch load inventory changes into a daily inventory movement table. Calculate the balance in a view that joins it to a historical inventory balance table. Update the inventory balance table nightly. So these are the four options. This question is about to create a near real-time inventory dashboard and also to process several thousands of updates to inventory every hour. So these are the two main points of this question. So since it's a near real-time inventory dashboard, we cannot use option D here. The option D is for batch processing, so we can eliminate option D here. That left with option A, B, and C. Before going to option A, B, and C, let's see a concept on the BigQuery quotas. So this is the screenshot from the above link. Here the following limits apply to BigQuery standard tables. The table operations per day is 1500 operations. Your project can make up to 1500 operations per table per day. So this is the limit applied on the BigQuery tables. So because of that reason, we cannot go for option A and B. The option A and B are mainly to use update statement to update the inventory tables as they are changing. And second one is partitioning the inventory table by item to reduce the amount of data scanned with each inventory update. So we cannot use this option A and B because the question is talking about several thousands of updates to inventory every hour. So we have to use option C here. Option C is the use the BigQuery streaming the stream changes into daily inventory movement table. So this is the correct answer for this question. Since it's a real time, streaming would be the right option here. The next question is you have a data stored in BigQuery. Data in the BigQuery dataset must be highly available. You need to define a storage, backup, and recovery strategy of this data that minimize cost. How should you configure the BigQuery tables? The four options are set the BigQuery dataset to be regional. In the event of an emergency, use a point-in-time snapshot to recover the data. The second option is set the BigQuery dataset to be regional. Create a scheduled query to make copies of data to tables, suffix with the time of the backup. In the event of emergency, use a backup copy of the table. Third option is set the BigQuery dataset to be multi-regional. In the event of an emergency, use a point-in-time snapshot to recover the data. And the fourth option is set the BigQuery dataset to multi-regional. Create a scheduled query to make copies of data to tables suffixed with the time of backup. In the event of emergency, use a backup copy of the tables. Here, the question is mainly about data stored in BigQuery and must be highly available here. Since it's highly available, we cannot store the data in the regional. Highly available in the sense it should be available in more than one region. So in that case, option A and B we can eliminate because option A and B talks about regional. So since it's a highly available, we should store the data in more than one region. So we can eliminate option A and B. They're left with option C and D. Before going to option C and D, let's quickly talk about BigQuery backup and recovery. So this screenshot is from the above link, backup and recovery. Managing backup and availability has always been a complex and expensive task for database administrators. The need for extra license and hardware can greatly increase cost. BigQuery addresses backup and disaster recovery at the service level by maintaining a complete 7 days history of changes against your tables. BigQuery lets you query a point-in-time snapshot of your data by using the table decorators or system time as of in the from class. So BigQuery we have this option and is like kind of less expensive, and we can use the point-in-time snapshot to recover your data. So because of this reason, we can choose option C here. Set the BigQuery dataset to multi-regional. In the event of emergency, use a point-in-time snapshot to recover the data. Whereas option D is more expensive compared to option C here. The next question is you use Cloud Dataprep to create a receipt on a sample of data in a BigQuery table. You want to reuse this receipt on a daily upload of data with the same schema after the load job with variable execution type completes. What should you do? The options are create a cron schedule in a Cloud Dataprep. The second option is create an app engine cron job to schedule the execution of Cloud Dataprep job. Third option is export the receipt as a Cloud Dataprep template and create a job in Cloud Scheduler. Fourth option is export the Cloud Dataprep job as a Cloud Dataflow template and incorporate it into a Cloud Composer job. Here the key point is the load job with variable execution time. So the job completion time is not fixed, so it's going to vary for each execution. Since the load job varies for each execution, we cannot use a cron schedule or a cloud scheduler because these two are mainly dependent on time. So when you set a time on the scheduler, at that time those jobs going to execute. But here the load job varies for each execution, so we cannot set this up ahead. So there's a dependency on the load job. So we can eliminate option A, B, and C, and we're just left with option D. Before going to option D, let's see a quickly about this Cloud Composer. So the screenshot is from the above link. So this link says like we're happy to announce the latest release of Cloud Dataprep with Expose Orchestration API, so you can integrate Cloud Dataprep within your schedulers or other orchestration solutions like Cloud Composer. This means you can expand your automation beyond Cloud Dataflow template through direct integration in other tools to create a repeatable data pipelines for your analytical AI and ML initiatives. So basically, like if you have any dependency setup is there, then you can use a Cloud Composer to have this orchestration. So here the best option is option D. Export the Cloud Data Prep job as a Cloud Data Flow template and incorporates it into a Cloud Composer job. The next question is you want to automate execution of a multi-step data pipeline running on Google Cloud. The pipeline includes Cloud Dataproc and Cloud Dataflow workflows that have multiple dependencies on each other. You want to use a managed service where possible, and the pipeline will run every day. Which tool should you use? The options are the first one is cron, the second one is Cloud Composer, third is Cloud Scheduler, and the fourth one is workflow templates on Cloud Dataproc. This is a straightforward one since we need to use the managed service here, so Cloud Composer is the correct option here. So if you see here, Cloud Composer is a fully managed workflow orchestration service built on Apache Airflow. So the correct answer is Cloud Composer. The next question is you are managing a Cloud Dataproc cluster. You need to make a job run faster while minimizing cost without losing work in progress on your clusters. What should you do? The first option is increase cluster size with more non-preemptible workers. The second option is increase cluster size with preemptible worker nodes and configure them to forcefully decommission. The third option is increase the cluster size with preemptible worker nodes and use Cloud Stack driver to trigger a script to preserve work. And the fourth option is increase the cluster size with preemptible worker nodes and configure them to use graceful decommissioning. So what we need to understand from this question is we want to make a job run faster, and also while making that we should not lose the work in progress on the clusters. How we can achieve this? Before going to the answer, let's quickly see about scaling of Cloud Dataproc cluster. The screenshot is from the above link. Scaling of clusters. After creating a Dataproc cluster, you can adjust the cluster by increasing or decreasing the number of primary or secondary worker nodes in the cluster. You can scale Dataproc cluster at any time, even when the jobs are running on the cluster. Next is why scale a Dataproc cluster. The first one is to increase the number of workers to make the job run faster, and the second one is to decrease the number of workers to save money. See graceful decommission as an option to use when the downsizing cluster to avoid losing work in progress. So our requirement is we want to make the job run faster while the jobs are running on the cluster. So this is one option where I can achieve this one. And once the jobs are done, we want to do a graceful decommission of the option as an option to downsizing cluster to avoid the losing work in progress. So this we can achieve using scaling of clusters in Cloud Dataproc. So the option here is the fourth option, the increase the cluster size with preemptive worker node and configure them to use graceful decommissions. In this case, we will not lose the work in progress on the clusters. The next question is you work for a shipping company that uses handheld scanners to read shipping labels. Your company has strict data privacy standards that require scanners to only transmit recipients' personal identifiable information to analytics systems, which violates user privacy rules. So you want to quickly build a scalable solution using cloud native managed service to prevent exposure of PI to the analytics systems. What should you do? Options are, the first one is create an authorized view in BigQuery to restrict access to tables with sensitive data. Then second option is install the third-party data validation tool on Compute Engine virtual machines to check the incoming data for sensitive information. The third option is use stack-table logging to analyze the data passed through the total pipeline to identify transactions that may contain sensitive information. Fourth one is build a cloud forming function that reads a topic and makes a call to the cloud data loss prevention API. Use the tagging and confidence level to either pass or contain the data in a bucket for review. So the question is like we need to build a scalable solution using cloud native managed service to prevent exposure of PI data to the analytics systems. How we can what we should do for this one. By looking at the options, we can vaguely say that A, B, and C cannot be the right answer because A here we are creating authorized view in BigQuery to restrict the access to tables with sensitive data. So we have to prevent this sensitive data to be exposed to the analytics system. So creating this will not help. The next one is instead third-party data validation tool. Again, so need to go for third-party data validation, which is not good for sensitive data. So the third option here is use track drive logging to analyze data passed through the total pipeline to identify transactions that may contain sensitive information. So the third option talks about analyzing data that already passed through total pipeline. So that's also not the right answer. So we are left with only one answer, D. So let's quickly see about cloud data prevention API. Then we'll come to a conclusion on this one. Cloud data loss prevention is a fully managed service designed to help you discover, classify, and protect your most sensitive data. So take charge of your data on or off cloud, gain visibility into sensitive data risk across your entire organization, reduce data risk with obfuscation and de-identification methods like masking and tokenization, seamless inspect and transform structured and unstructured data. So with the help of this one, we can easily say that the option 4 is the option D is the right answer here. So build a cloud function that reads the topic and makes a call to the cloud data prevention API. Use the tagging and confidence level to either pass or contain data in the bucket for review. Moving on to the next question. You have developed three data processing jobs. One executes a cloud data flow pipeline that transforms data uploaded to cloud storage and writes results to BigQuery. The second ingests data from on-prem servers and uploads it to cloud storage. The third is a cloud data flow pipeline that gets information from third-party data providers and uploads the information to cloud storage. You need to be able to schedule and monitor the execution of these three workflows and manually execute them when needed. What should you do? The first option is create a direct acyclic graph in Cloud Composer to schedule and monitor the jobs. Second option is use track-driven monitoring and set up an alert with webhook notification to trigger the jobs. Third option is develop an app engine application to schedule and request the status of the jobs using GCP API calls. The fourth option is set up cron jobs in Compute Engine instance to schedule and monitor the pipeline using GCP API calls. So this is kind of a straightforward answer. So before going to the answer, like just quickly talk about orchestration here. So this screenshot is from the above link. So if you see at the right, I want to orchestrate. So if it's a service or a data driven, if it's a service, whether it's a single service or a microservice. If it's a single service, then we can go for cloud scheduler, and if it's microservice, we can go for workflows. But in case of data driven workloads, we can use cloud composer. So because in this question all the things are data driven, so the cloud composer is the right answer here. So if you see the left, you could see the cloud composer definition. It's a fully managed workflow orchestration service built on Apache Airflow. You can author, schedule, and monitor pipelines that span across hybrid and multi-cloud environments. Built on Apache Airflow, open source project, and operated using Python. Frees you from lock-in and is easy to use. And if you see about writing DAGs, so this guide show how to write an Apache Airflow DAG that runs in a cloud composer environment. So by looking at this, you can easily say that the first option is the right answer. The next question is, you have a cloud function written in Node.js that pulls message from cloud PubSub and send the data to BigQuery. You observe that the message processing rate on the PubSub topic is order of magnitude higher than anticipated, but there is no error logged in the stack driver log viewer. What are the two most likely causes of this problem? The options are, first option is publisher throughput quota is too small. The second option is total outstanding message exceed the 10 MB maximum. Third option is error handling in the subscriber code is not handling runtime errors properly. The fourth option is the subscriber code cannot keep up with the messages. The Last option is the subscriber code does not acknowledge the message that it pulls. This question is about you observe that message processing rate on the PubSub topic is higher than the anticipated, but there is no error logged in the stack driver log viewer. So what are the two causes for this issue? Let's go through each of the answer here. The first one is publisher throughput quota is too small. So if the publisher throughput quota is too small, then we will not able to publish the message to the topic. So but here we are saying that magnitude is higher than anticipated. So in the case we are publishing more than the expected. So the first option is not the right answer because we are saying the quota is too small. If it is too small, then we cannot publish the message. The second option is total outstanding message exists 10 maximum MB maximum. So again here we are talking about if the message exceeds 10 maximum MB, we cannot publish the message to the topic, and so this is also not the right answer. The fourth option, the subscriber code cannot keep up the messages. Since we are using cloud function here, it's auto scalable, so obviously there will not be any problem in keeping up the messages. So fourth option also not the right answer. So we are left with option C and E. And if you see, go to option E, and the subscriber code does not acknowledge the message that it pulls. Since the subscriber did not acknowledge the messages, that's the reason the PubSub keeps sending a message to the topic. That's why the magnitude is higher than anticipated. That is the one right answer. Other answer is error handling. The subscriber code is not handling the runtime errors properly. Since the error handling is not handled properly, the PubSub keeps sending the messages to the topic. That's why we could see the more magnitude than the anticipated messages. So the correct answers are C and E. The next question is, you're creating a new pipeline in Google Cloud to stream IoT data from Cloud PubSub through Cloud Dataflow to the BigQuery. While previewing the data, you notice that roughly 2% of the data appears to be corrupt. You need to modify the Cloud Dataflow pipeline to filter out this corrupt data. What should you do? Options are, the first one is add a side input that returns a boolean if the element is corrupt. Second option is add a Pardo transform in Cloud Dataflow to discard corrupt elements. Third option is add a partition transform in Cloud Dataflow to separate valid data from corrupt data. Option 4 is add a group by key transform in Cloud Dataflow to group all the valid data together and discard the rest. Here the question is, we need to modify the Cloud Dataflow pipeline to filter out this 2% corrupt data. How we can achieve this in Cloud Dataflow? Let's quickly see about Pardo transform. This screenshot is from the above link. The Pardo. The Pardo is a beam transform for generic parallel processing. The Pardo processing paradigm is similar to the map phase of map shuffle reduce style algorithm. The Pardo transform considers each element in the input P collection, performs some processing function on that element, and emits 0, 1 or multiple elements to an output P collection. So the Pardo is useful for a variety of common data processing operations, including filtering datasets. You can use Pardo to consider each element in the P collection and either output that element to a new collection or discard it. So for our question, we need to filter out this 2% corrupt data. So we can use a Pardo transform to filter out those corrupt data. So the right option is B here.